glassware is one of the versatile and objects that was created by man. It is defined as object or containers made from glass. The glass is an organic, transparent, rigid, non-crystalline, and versatile material made up of a mixture of metal oxides at high temperature. Glassware is used to store, mix, measure, deliver, and store biological and chemical substance or reaction in laboratories. It is ideal for lab setting as glass doesn't react with chemicals, so test result will not be altered. Furthermore, the glass is transparent, so it is easier for monitoring the substance, and glass is heat resistant when using in high temperature. Glassware can be divided into two groups. The first group would be non-volumetric glassware, while the second group would be volumetric glassware. For non-volumetric glassware, they consist of two apparatus, that is, beaker and flask. Flask is used to contain a certain volume, while beaker is used for transforming liquid to another container. While for volumetric glassware, there are four apparatus, that is, volumetric flask, pipette, burette, and graduated cylinder. Volumetric flask is used for preparation of standard solution. Other than that, pipette is used for transfer liquid between containers. Burette is used for titration, accurate in dispensing of liquids of solution. Last but not least, graduated cylinder is in the use of rapid measurement of liquid volume, semi-accurate liquid measuring vessels.
Pharmaceuticals, known as drugs or medicines, are substances used to prevent, diagnose, treat or cure disease, medical conditions or disorders in humans or animals. They are created through a complex process involving research, development, testing, and manufacturing. Next, we will talk about how to calibrate volumetric flasks that used in pharmaceuticals. Okay, first of all, you have to weight a clean and dry volumetric flask. Next, you need to calibrate the flask by filling it with recently boiled and cold distilled water at room temperature up to the mark, and after that, weight the flask. Lastly, you can determine the volume in ml by using the formula volume in ml equal to weight in gram divided by 0.99602 gram, where 0.99602 gram is the weight of 1 ml water determined at temperature 25 degrees Celsius. For the volumetric flask having capacity more than 100 ml, dispense the water from 100 ml burette class A in multiple steps if required, and not define the volume. For example, total volume dispense.
Next, let's continue with the methodology for cleaning glassware using a cleaning solution. There are 5 cleaning solutions that I will explain. The first one is water detergent. A brief soaking in a warm detergent solution is usually sufficient to remove the grease and dirt. The second one is aqua regia. Aqua regia is a very powerful and extremely corrosive cleaning and dangerous solution. It is not typically used for routine cleaning of glassware, but rather for specialist purposes such as removing stubborn contaminants or dissolving certain metals. The third one is dilute nitric acid. Dilute nitric acid, commonly known as nitric acid solution, is a milder form of nitric acid that is used for cleaning glassware in various laboratory and industrial settings. It is used to remove foams which adhere the inside of glass and bottles, followed by multiple rinses with distilled water. Other than that, dichromate sulfuric acid. Dichromate sulfuric acid, also known as chromic acid solution, is a mixture of concentrated sulfuric acid. It is particularly effective at removing organic contaminants such as grease, oil, and stubborn residues from glassware surfaces. To prepare the solution, dissolve sodium dichromate in water and continuously add with stirring concentrated sulfuric acid. The last one is ultrasonic. The glassware is soaked in a warm detergent solution through which is passed acoustic energy of frequency. The ultrasonic vibrations dislodge dirt and grease quickly from the glass in 5 to 10 minutes.
From the previous slide, we can see the table that displays example accurate measurement using volumetric flask and 1. Pipette. The accuracy of volumetric glassware such as volumetric flask and pipette is determined by their tolerance limit, which is the maximum allowable difference between the actual volume of the container and the volume it is supposed to contain. The smaller the tolerance limit, the more accurate the measurement. That means the range of acceptable value is also small, resulting in a more accurate measurement. It is important to us to use container with the correct tolerance limit and subdivision to ensure accurate measurement. Besides that, volumetric glassware such as volumetric flask should be calibrated regularly to ensure their accuracy. Over time, volumetric glassware can be worn or damaged, which can affect their accuracy. By calculating the volumetric glassware, we can determine its actual volume and compare it to nominal volume for calculate the error and replace it if necessary. Inaccurate measurement due to poorly calibrated volumetric flask can lead to error in chemical calculate, which can have significant consequence. For example, if the concentration of the solution is calculated using incorrect calibrated volumetric flask, the actual concentration may be significantly different from the calculated value. This can lead to incorrect experiment result and conclusion. This helps to ensure that the data we obtain from the experiment are as accurate as possible.
In conclusion, to get the most accurate result, volumetric glassware need to be calibrated in order to measure the volume that is contained in or delivered by a particular glassware. By selecting the appropriate cleaning solution, it is important for glassware to be effectively clean, ensuring accurate and reliable results in laboratory and industrial environments.
The calibration process includes cleaning and drying of the flask, followed by carefully measuring a known volume of liquid.
So, in conclusion, by selecting the appropriate cleaning solution, it is important for glassware to be effectively clean, ensuring accurate and reliable results in laboratory and industrial environments.
Calibration of glassware is crucial in laboratory work to ensure that the measurements obtained are accurate and precise, leading to reliable and valid results.